You're at a party. The room is loud, maybe 30 people all talking at once. You've been stuck in one conversation for 10 minutes. The person across from you is explaining something about their job. You're nodding. You can't hear them clearly. There's music. There are 3 other conversations happening within arm's reach. And then from across the room, through all of that noise, you hear your name. Not shouted, not repeated, just once, in a normal voice, from a stranger you weren't watching. You turn. You catch a fragment of a sentence that wasn't meant for you. The person in front of you is still talking. You missed whatever they just said. Most people assume this is coincidence, a lucky catch. The sound just happened to cut through at the right moment. It isn't. Your brain was listening to every conversation in that room, simultaneously the whole time. You weren't aware of it. But a part of you was attending to every voice, every word, running continuous pattern recognition on audio you thought you were ignoring. And out of everything it heard, it flagged one thing as important enough to interrupt you. This has a name. Psychologists call it the cocktail party effect. It was first formally described in 1953 by a British cognitive scientist named Colin Cherry. Cherry was working at MIT. He was trying to understand how people separate one audio signal from another when multiple signals arrive at the same time. He ran a series of experiments called dichotic listening tests. Participants wore headphones. A different message was played into each ear simultaneously. Subjects were told to repeat back, word for word, the message in their right ear. This is called shadowing. It requires intense focus. While they shadowed, Cherry changed the message in the unattended ear. He switched it to German. He played it backwards. He replaced words with a pure tone. Subjects noticed almost nothing. They couldn't recall a single word from the unattended ear. Most didn't even notice when the language changed entirely. Cherry concluded that attention is a filter. The unattended channel carries almost no semantic content into conscious awareness. This became the dominant model in cognitive psychology. For the next 6 years, in 1959, a researcher named Neville Morey decided to test one exception. Morey's question was simple. What if the unattended ear heard the subject's own name? He ran the same dichotic listening setup. Subjects shadowed the attended message. The unattended channel played a list of random words, including each subject's first name. About 1/3 of participants heard their name. They broke from the task. They turned their head. They asked if someone had said something. 1/3. In conditions specifically designed to suppress attention to the unattended channel, Morey called this a crack in the filter model. If attention was a true filter, no semantic content should leak through. But names leaked. For 30 years, the study was replicated in various forms. The results stayed roughly consistent. Names were special. They got through when other words didn't. In 1995, researchers Neff Wood and Nelson Cowan at the University of Missouri ran the most rigorous version of the experiment to date. They controlled for a flaw in Morey's original design. Subjects in early experiments often heard their name because the shadowing task wasn't demanding enough. The filter was never properly loaded. Wood and Cowan made the primary task genuinely hard. Then they embedded subjects' names in the unattended stream. Detection dropped, but it didn't disappear. Roughly 35% of subjects still heard their name under conditions of high attentional load. A different word with the same phonetic length. Detected less than 10% of the time. The name was special. The statistical gap was not subtle. The question researchers kept returning to was how. If you are genuinely not monitoring the unattended channel, how does your name get through? The answer requires understanding something about how the brain processes language at a level far below conscious thought. When sound enters your ear, it doesn't go directly to consciousness. It travels through a sequence of processing stages, each extracting more meaning from the signal. The earliest stages handle basic acoustics, frequency, rhythm, volume. This happens in the brainstem and primary auditory cortex, entirely involuntarily. Higher stages extract phonemes, then words, then semantic meaning. And at some point along that chain, a decision is made. Does this reach awareness? For most inputs in a noisy room, the answer is no. The signal is processed and discarded before it crosses the threshold of conscious perception. But your name is encoded differently. From the earliest years of your life, your name is attached to you. It signals food, safety, danger, comfort, correction. It means, this is about you. Pay attention. Over years of repetition, your brain builds an exceptionally strong neural representation of that specific phoneme sequence. It becomes one of the most deeply wired patterns you carry. Researchers at the University of Oregon, and later at Cambridge, found that your name activates broader neural networks than comparable words. more cortical area, more robust signal. Your name bypasses ordinary gating mechanisms because it is flagged, at a hardware level, as personally relevant. The system routes it forward before you decide to listen. This involves a structure deep in the temporal lobe called the amygdala. The amygdala is often described as the brain's threat detector. That's partially accurate, but too narrow. It is more precisely a salience detector. It monitors for anything that matters. Threats matter, but so does your name. Both activate the amygdala, which then modulates attention upstream, signaling that something in the input stream deserves a closer look. In neuroimaging studies, hearing your own name produces measurably stronger amygdala activation than hearing someone else's name. The response is automatic. It does not require intent. There is a separate line of evidence that makes this point in a more striking way. In 2006, a team led by neuroscientist Fabrice Perrin at the University of Lyon ran EEG experiments on sleeping subjects. They played names through speakers while subjects slept. Sometimes the subject's own name, sometimes a stranger's name. The sleeping brain responded differently to its own name. The P300 component, an electrical signature associated with attention and stimulus evaluation, was significantly larger for self-referential names. They were asleep. They were not making decisions. The brain was doing it without them. A 2011 study at the University of Western Ontario went further. They tested patients under general anesthesia, full surgical sedation. Even under anesthesia, the brain showed measurable differential response to the patient's own name versus other names. The processing was still happening. The system was still running. You do not control this. You never could. The surveillance was always on. This extends into waking life in ways most people don't track. You process enormous quantities of sensory information every second. You are conscious of almost none of it. Your brain maintains a continuously updated model of the auditory environment. It runs predictions about what sounds mean, who is speaking, whether anything requires action. This is called predictive processing. The brain isn't passively receiving input. It is actively modeling the world and flagging deviations from expectation. Your name deviates from the statistical norm of background noise, not because it's loud, because it's meaningful. The model recognizes it as belonging to a special category. There is something quietly unsettling about this, if you sit with it. You believe you choose what to pay attention to, and for many things that's roughly true. You can redirect your gaze, change the channel, close the browser tab, but at the level of sensory processing, attention is not fully under your control. Something else makes the first cut, and that something else has preferences you didn't choose. Your name is one of them, but it isn't the only one. Research on threat-relevant stimuli shows the same bypassing effect for angry faces, snake-like shapes, sudden movement. The brain has a priority queue, and it was built before you had opinions about it. Advertisers figured out a version of this decades ago. A voice that addresses you directly, by name or by implication, using the word you, activates different processing than third-person copy. More personal, more intrusive, harder to dismiss, personalized audio advertising. Call centers trained to use customers' names repeatedly, the specific cadence of a sales call. These are all applied versions of what Moray measured in 1959. They are reaching into the same mechanism. There is a philosophical thread here worth following. Your name was given to you. You didn't choose it. And yet, over the first years of your life, your brain wired itself around that sound so thoroughly that it now bypasses your own attentional gatekeeping. Something you had no part in selecting became one of the most deeply embedded features of your perceptual system. We think of identity as something we build or choose, but a significant portion of it is simply installed at a level we cannot reach and did not consent to. When you hear your name in a crowded room and turn, you are experiencing that installation running. It isn't you deciding, it is the architecture deciding for you. And the architecture was built by other people in the first years of your life, long before you had any say in the matter. Go back to the party. The room is loud, 30 people, multiple conversations, music, you're nodding at the person in front of you. Somewhere in your temporal lobe, a processing cascade is running in parallel, scanning the acoustic environment for what matters. Your name surfaces, the amygdala flags it, attention shifts, you turn. For a moment, you are not choosing what to pay attention to. The system is choosing for you based on preferences installed in your first years of life. That happened. It keeps happening. It will keep happening in every crowded room for the rest of your life. The cocktail party effect is usually framed as a neat, perceptual trick, a curiosity, evidence of how impressive the brain is at passing noise. But it is also a reminder. There are processes running inside you, right now, that you have no access to. They are making decisions before you know a decision is needed. Some of those processes are ancient, tuned to threats that mattered millions of years ago. Some of them are personal, shaped in the specific first years of your specific life, by people whose voices you might not even remember anymore. All of them are you, just not the part of you that you're aware of. You heard your name across a crowded room. You thought it was chance, good hearing, a lucky catch. It wasn't. Your brain was listening the whole time. It just didn't tell you.